My dear students, in my previous video, we have solved some problems under the topic differential equations using the method variable separable. In the next method, homogeneous differential equation. So the second method is the differential equation topic, that is homogeneous differential equations. What do you mean by homogeneity? Homogeneous differential equation means an equation, a differential equation f of xy is a differential equation in x and y. Homogeneous means the variables x and y are of same degree. The degree of the differential equation should be equal. F of xy is t power n. This is f of xy. That is, this f of xy can be replaced by, this x and y variables can be replaced by f of tx comma ty, where t is a constant, x and y are variables. If f of xy by g of xy, it is the differential equation form. This is dy by dx equal to f of xy by g of xy. So both numerator and denominator are true functions in x and y. These f of xy or g of xy, you can replace x and y by tx and ty, where t is a constant. Then t power n into f of xy can be restricted this equation into the t power n into f of xy. In this case, the f of xy is a homogeneous equation in x and y of degree n. Both numerator and denominator are of same degree. This is, suppose it is t power n and denominator also t power n. So this can be expressed as t power 0 f of xy comma g of xy. So t power n by t power n is t power n minus 1, that is t power 0. So this is a homogeneous equation in x and y of degree 0. Like that, the homogeneous differential equation is defined. That is, homogeneous differential equation is an equation in the variables x and y of degree n. It can be expressed as t power n into f of xy, where t is a multiple, t is a constant. T is a constant. The f of x comma y is a homogeneous. F of xy is a homogeneous differential equation. F of xy is a homogeneous differential equation in variables x and y. F of xy is a homogeneous differential equation in x and y of degree n, where n is any real number. N belongs to the set of real number, where n is any real number. If x and y are replaced by tx comma ty, then it is expressed as t power n into f of xy. This is the definition. F of xy is a homogeneous differential equation in x and y of degree n, where n is r. If f of tx comma ty is equal to t power n into f of xy. If this condition is true, then it is a homogeneous differential equation in x and y of degree n. This is a definition for a homogeneous differential equation. Whereas in the case of CBSE syllabus, so this homogeneous differential equation is given both in state board syllabus and in the CBSE syllabus. In the CBSE syllabus, the constant t can be replaced by some constant lambda, lambda x comma lambda y equal to lambda power n into f of x comma y. So in this case, f is also given as some capital F. In CBSE syllabus, t is replaced by lambda and the function f is replaced by some capital F. That's all. F of lambda x comma lambda y equal to lambda power n into capital F of x comma y is a homogeneous differential equation in x and y of degree n, where lambda is a constant. See, this is the definition given in CBSE syllabus, CBSE textbook. This is in the state board textbook. It's just the constant is default, that's all. So now I am going to give some examples of differential homogeneous differential equation. Homogeneous differential equation, I already told you the degree of a differential equation should be same. The degree of the variables x and y are of same degree. Then we say that the equation is homogeneous. Example of a homogeneous differential equation is example 1. The f of x comma y equal to 6x square plus 2xy plus 4y square. See, check whether it is a homogeneous differential equation. You replace x by tx and y by ty for checking the homogeneity. You replace x by tx and y by ty. See tx whole square. Instead of x, you write tx. Instead of y, you write ty plus 4 into ty the whole square. This is 6 t square x square plus 2t into t square xy plus 4 t square y square. You can find a t square in all the three terms. You can take that t square as a common term, 6x square plus 2xy plus 4y square. T square into 6x square plus 2xy plus 4y square. This is t square into 6x square plus 2xy plus 4y square is nothing but f of x comma y. So f of tx comma ty equal to t square into f of x comma y we have seen. Therefore, it is a given equation is a homogeneous differential equation of degree 2. Therefore, the given equation is a homogeneous homogeneous differential equation. It is an homogeneous differential equation. It is an homogeneous differential equation of degree 2. This is an example of a differential equation. Okay, one more example. Example number 2. dy by dx equal to x cube plus y cube by 2x cube minus xy square. In this equation also, you replace x by tx whole cube, y by ty whole cube, x by tx, y by ty whole cube by 2 into tx whole cube minus tx into ty whole square. So this is equal to t cube x cube plus t cube y cube by t cube 2t cube x cube minus x t square into t cube xy square, because this t square into t is t cube xy square. See, in the numerator you can take t cube common, in the denominator also you can find t cube as a common term. So in this example, you take t cube both in the numerator and denominator as a common term. So this topic is common for both the syllabus, for state board and CBSE. dy by dx equal to, you can take t cube in the numerator common, you will get x cube plus y cube by denominator also you can take t cube common, 2x cube minus xy square. T cube by t cube is t power 0 into x cube plus y cube by 2x cube minus xy square. See, this is nothing but f of xy. X cube plus y cube by 2x cube minus xy square is the given problem. T square of f of x comma y. T power 0 in f of x comma y. Therefore, the given function is a homogeneous function of degree 0. So, this is a homogeneous differential equation. Given equation is here. Given equation is an homogeneous equation. Homogeneous equation of degree 0. It's also a homogeneous equation of degree 0. Therefore, you can find the second example also is homogeneous differential equation. It's of degree 0. First equation is homogeneous equation of degree 2 we have seen. So, next, before going to solve the problems, I am going to give one more example. Non-homogeneity. Homogeneity fails in an equation. It is I am going to give an equation, an example for non-homogeneous equation. See, consider this problem. Consider this example, 2x cube minus xy square dy equal to x cube plus y square into dx. Check whether this equation is homogeneous or not. From this, you have to rewrite this equation is dy by dx equal to, numerator is x cube plus y square, by denominator this term, left hand side term, you bring it to the denominator, 2x cube minus xy square. So the above problem can be expressed as dy by dx, dy by dx equal to x cube plus y cube by 2x cube minus xy square. You bring this, bring the left hand side term to the right hand side, it becomes into the denominator. Now you replace x by tx, t cube x cube. If you put t for x, tx for x, t cube x cube. This is for t square y square by 2x cube is 2 t cube x cube minus tx into t square y square. So in this equation, the numerator, you can find t square only common. Therefore, you get tx cube plus y square by, in the denominator you can take t cube common. You will get 2x cube, t square into t cube is xy square. T square into t is t cube. If you can take t cube common, you will get xy square. So t square by t cube, it is, numerator is of degree 2 and denominator is degree 3, therefore it is not homogeneous. See, in both numerator and denominator functions should be of same degree, then only we can say that the equation is homogeneous. In this case, numerator is of degree 2, denominator function is of degree 3, this is not equal, therefore the given problem or given equation is not homogeneous. The given given equation is not homogeneous. This is non-homogeneity. This is an example for non-homogeneity because degree of numerator and denominator differ. Therefore, the given equation is not homogeneous. Okay. Next, I am going to solve one problem using this homogeneous differential equation method. To solve this type of equations, we have to replace y equal to Vx. That is the substitution we have to give. To solve this differential equations, homogeneous differential equations, you have to substitute for y as Vx. Y, we have to see, solve, example, solve x dy minus y dx equal to root of x square plus y square dx. Check whether the equation is homogeneous and solve. That is the problem. You have to check the homogeneity of this equation and then you have to solve whether this equation is homogeneous. If it is homogeneous, you have to solve the equation. To solve, first you have to x dy, you keep as it is and you bring this dx down to right hand side. Y dx plus root of x square plus y square, both are common and you can take dx as common term. You bring this y dx minus y dx to the right hand side, this plus y dx. You can take dx common, y plus root of x square plus y square d into dx. Okay. Now dy by dx equal to y plus root of x square plus y square by x. This x, left hand side x comes to the denominator to the right hand side. Now you replace y and x by tx ty. This is ty plus root of t square x square. Y square is t square y square by x is tx. So in the numerator ty, you can take t square from the square root, you will get only t. Square after taking out of t square from the square root, it is t. Therefore t into x square plus y square by tx. So numerator you can take t common, you will get y plus root of x square plus y square by tx. T by t, this becomes t power 0, y plus root of x square plus y square by x. So this is the problem. Y plus root of x square plus y square by x, dy by dx is this. Therefore, it is a homogeneous differential equation of degree 0. So the given equation is a homogeneous differential equation of degree 0. It is a homogeneous differential equation of degree 0. Now we have to solve. It is a, you can write here, it is a homogeneous differential equation of degree 0. It is a homogeneous differential equation. It is a homogeneous differential equation of degree 0. We have checked the homogeneity first and then we have to solve. Dy by dx is, this is your step. To solve in this step, you replace y by vx. That's our next idea. So to solve this differential equation, substitute or put y equal to vx. And v and x are functions of x. V is a function of x or constant. V is a function of x or constant. So if you put y equal to vx, what is dy by dx? v and x are functions of x, v in the derivative of x is 1 plus x in the derivative of v is dv by dx. If v is a function of x, v is a function of x. If it is so, function of x only you consider. V is a function of x. Then only we are differentiating v with respect to x. V in the derivative of x is 1 plus x in the derivative of v with respect to x is dv by dx. So dv by dx is v plus x dv by dx. So in the place of dv by dx, we replace v plus x dv by dx equal to right hand side y equal to vx plus root of x square plus y, instead of y you have to put vx, therefore vx whole square by x only. See, in this case, vx, here you have v square common. V square x square. X square, if you take x square as common term, x square within the square root, you can take x square as common term, you will get x only. X into root of 1 plus b. Because I am taking x as a common term, root x square as a common term, it is out. While you take from the square root, it becomes x. X into root of 1 plus b. 1 plus, what is it? V square. V square. Because v square x square can taken out, you will get v square only. 1 plus v square by x. Now in the numerator you can take x as a common term. You will get v plus root of 1 plus v square by x. X cancel. You will get x cancel in the numerator and denominator. You will get v plus x dv by dx equal to, and erase here, like solve it. See, if v plus x dv by dx equal to v plus x dv by dx, left hand side is equal to x cancel, you will get v plus root of 1 plus v square. See, I can take v on both sides, and you will cancel v on both sides, you will get, or if you bring it to the right hand side, it becomes v cancel on both sides. You will get x dv by dx, v cancelled on both sides, you will get x dv by dx equal to root of 1 plus v square. So using variable separable here, you have to separate v terms and x terms. You will get 1 by root of 1 plus v square or v square plus 1. You write 1 plus v square by v square plus 1 also. 1 by root of v square plus 1 into dv equal to x by dx. If you bring it to the right hand side, it becomes dx by x. So we are substituting y equal to vx. We are replacing y equal to vx for the purpose of separating the variables v terms and x terms separately. So homogeneous differential equation, after giving substitution y equal to vx, we are converting into the variable separable type, and we are separate v terms and x terms one side. And now you have to integrate, you will get the answer. You will get the solution. So now again integral 1 by root of v square plus 1 dv equal to integral dx by x. So integral 1 by v square plus 1 is log of, on differentiation you will get one by v square plus 1 is log v plus root of v square plus 1. Log of integral 1 by x square plus 1 is log x plus root of x square plus 1. That is the formula for integral 1 by root of x square plus 1. Formula is 1 log of x plus root of x square plus 1. Using this idea, integration of 1 by v square plus root of v square plus 1 is log v plus root of v square plus 1, and this is integral dx by x is log x plus, since all the terms logarithm we have, constant is also log c. So this is log m plus log n is log m, and you will write it as log cx. Here log v plus root of v square plus 1. So eliminating logarithm on both sides, you will get v plus root of v square plus 1 equal to cx. Now you replace v by y equal to vx. So given a substitution for y equal to vx, from this you will get v equal to y by x. From this expression, since y equal to vx, v equal to y by x. Finally, you replace v by y by x in the solution. You will get v is y by x plus root of v square is y square by x square plus 1 equal to cx. Now again, y by x plus, you can take LCM x square as a common LCM term in the square root, within the square root, x square, y square plus x square, y square plus x square equal to cx. Again, this is y by x plus root of y square plus x square. I can write as x square plus y square. In the numerator, denominator root of x square is x equal to cx. See, common LCM, this you can take x as a common LCM term, you will get y plus root of x square plus y square equal to c into this denominator x. If you take denominator x to the right hand side, it is x into x square. The left hand side denominator x goes to the right hand side numerator. Therefore, y plus root of x square plus y square is cx square. So this is the solution for the given differential equation. This is the solution for the given differential equation. So a homogeneous differential equation can be solved like this one. Okay? So shall I stop here, and I will continue the next problem in the next video. Thank you.